Okay, so now we look at another example on the polar where that it is not non-rectangle, which means that we deal with something instant. Okay, so here we have we are given the double integral. There are a circle. Okay, as you can see, radius of the circle is 1, and that circle is cut off by the line y equal to x. So now we have circle, okay, but the circle is not centered at the origin. Okay, so A over the region is part of the circle squared plus minus 1 squared. So we sketch it looks so this is, and this is 1, this is minus 1. So the circle on y-axis. Okay, so in this case you have a circle, part of circle, the line of y to x. So y, so the line, let's say that 1. So obviously that is our region. Okay, so our region part of curve with radius centered at 0, 1, and also bounded to y equal to x. So now they don't mention about, or they don't ask you to, you have to think which coordinate system is the most appropriate one. Okay, so you should know when we should use the polar. So you should use the if you have the region which is part of the circle. So doesn't matter the circle is centered or not centered like this. As you can see there is polar equation. Okay, even though we can find it. Alright, we know that we should use the polar. We have okay, but this is not centered at the function of polar equation. So in this case, you have to convert everything into theta, and they are not given, right? So to find it, so in this case, okay, now we are thinking about the converting all the information regarding the region. So you have to convert polar equation. You have to convert the equation of circle in Cartesian into polar as well. Okay, and so this one is actually the condition of what you have done in engineering function. Okay, so if you don't remember, you have forgotten all about the polar, then you have to go back to your notes or books or it just there are very many about the polar. In fact, the graph itself you can. Okay, so now the equation of the circle is. So you have to it looks like you have to expand this one. Have the x squared plus y squared is 1 minus 2y. So yes, y equal to 1. Okay. So 1 and 1 cancel out. Then you have x squared is r squared to r sine to 0. Okay, so now you already obtain the equation in polar, but still not in the general form. I told you before, you have to realize what the polar equation and also the graph equation, the basic thing about the polar graph and so on, because it will to this question. Okay, so now it looks like we have r squared and r, and we can factorize the r. So r minus 2 sine theta equal to 0. And from there you can have r equal to 0 and also r equal to 2 sine theta. So what can you have from these two equations? What is r to 0? That if I give you, if r1, what is that? Radius 1, right? Center is about r0. Imagine you have a point. So meaning that the r0 graph that you have there, right? So if you don't remember that, then you have to go back to the polar graph. Okay, so about the polar graph, then you have to back to your notes, your books, and you can just go googling. So you can find there are very mention about the polar out there. Okay, so now you to look at the graph of two signs. It is part of the rose petal graph. So petal, if you have an of petal that you have, follow the number. So you have one single petal, then you have a three petal. For the even number, so two. If you have two theta, so it becomes four. If you have becomes eight and so on. Okay. But elaborate rose petal as in the exam is normally this one. Okay. So how can you know that? But then they just shifted now because symmetrical about the okay. I always remember that cos always to add should have the circles and symmetrical because y always is always related. So for if symmetrical along the y here. So now look at that you have sketched just now. So this is in a Cartesian. You given the answer the you got 2 sine theta. So now you look at the graph over. So but this one is given in Cartesian. This one is here a single graph by two different coordinates. So in Cartesian, so this is the equation. This is the equation. Okay, the A that right general. So A means the diameter. So okay, what I'm trying so this convert this into and R0 is the dot at the origin graph as well, but not the whole graph. As we know that the polar is non. So now we have the it's in polar. So how can equal to R thing sine over cos theta over R. So the correct way is actually cos theta where we can rewrite that because we want to train where there is no more x is at the origin. So we should have R0. So we just a single dot. It's not a graph. R equal to 0 will be part of y equal to x. The graph in y equal to x. Okay, and then here the tangent. Now we already have the next. We need to rewrite that. Okay, thing between 0 and pi over 2 and pi over 4 because we know that the theta is on the answer. You have learned this straight line. You draw a line 45 degree where actually this one is the representation. This line is the representation. So reason for this line is y equal to theta equal to degree, or in radian. In polar, this line is theta equal to pi over 4. Okay, r equal to the equation of into your integral. So you have to convert in r. So now we r cos theta. Okay, the limit. So now look here. Because you can see that so meaning that you're starting from 0. So because we know y axis, so the angle starting from 0 is a y axis. So y axis which is part of the so that you have to consider it. So we take and then now we see that the maximum angle, the point angle that we can see with line of y equal to x, which is in this over 4. Use 45 degree because it will be in radian. Okay, theta. How about the limit of r? Always use the order in polar dr theta and your limit of a function. Okay, or just one of them should be function of the r. How can we one or just enough for one? Okay, so in the r0, is it possible? R0 is 0 is part of the region, isn't it? Okay, and then the length. Okay, the length highest r here and over there, and see that point here is belong and 0 to 2. Okay, so we evaluate r square pi over 4. Okay, firstly, so replace r theta and so 1 over 3 minus we can have 1 over 3 8 over 3 theta d. So now appropriate of integration and integrate them, right? The most possible one is using so sine theta. So now we should and then u cube du or eliminate the expression becomes simpler. Then we can over 4 limit is on the u into theta 3 and 4 theta 4. Okay, then you have to evaluate the case that, as I mentioned before, you have not 45, the calculator. If in degree, okay, so you have to then you have to make sure your calculator, okay, set in radian. Okay, then after you substitute, so we know that simplify, the answer is 1/6. Then changing polar. So you have to convert to the double integral polar.